Do you really know what you eat? When you buy your food, what's behind what you can see? In Ecuador, around 946.4 million of tons of meat are produced each year. But an astonishing fact is that at least 64% of people who consume it are at risk of foodborne diseases. But why does this happen? Putrescine is a toxic substance produced by microorganisms when the meat is spoiled. The odor not so nice. So, if you consume this meat, it could intoxicate you. And even if you doubt it, food poisoning is much more common than you think. The symptoms of food poisoning are stomachache, weakness, or even diarrhea. It is awful. Here in Latin America, 600 million of food poisoning are reported, and Ecuador is no exception. This means that thousands of people have to go to hospital because the consequences of poisoning can be lethal. So, this is becoming a general public health problem in Ecuador. When we are at the supermarket, how can we be sure that the meat we buy is fresh and has been stored respecting the cold chain? What could happen if we had a device that allows us to detect situations leading to these diseases and prevent them?
Here we present you Pop Fresh Plus. Our label is made with a biosensor that changes the color of the label depending on the concentration of putrescine, allowing us to check if the meat is fresh in real time.
How does it work?
First, the label comes in contact with the meat. Then you press down on the label until you hear up. Wait for the detection to occur. If the label turns blue, the meat is safe for consumption, but if it turns red, it's better not to do so.
With our Pop Fresh Plus label, we can guarantee the meat quality from the producers to the end consumer. Most importantly, we are taking care of our health and well-being while reducing food waste in a sustainable way. The Pop Fresh label is made with cellulose, a biodegradable material that contains the putrescine biosensor, a chromoproteins blue and red, and a gene circuit in a cost-effective cell-free system. All in one!
A cell-free system is an in vitro tool that we can use to make the same biological reactions happen inside cells, but without having living cells. Isn't that great? With the cell-free system, we can produce proteins, manufacture therapeutics, and even develop biosensors like the putrescine biosensor. What's remarkable about the cell-free system is that by removing the complexity of living cells, we can precisely control the components and condition of a system, such as the amount of polymerases, ribosomes, the cell machinery, and the DNA we want to produce.
Some of the key components of the cellular machinery responsible for gene expression come from bacterial cell extracts. As a chassis to produce our cell-free system, we use E. coli Nisol, a bacterium that is harmless for humans that has already been used as a probiotic and represents a biosafety level 1. So, don't be afraid of this bacteria. It is amazing how bacteria can be so useful and versatile in our daily lives. The CFS doesn't involve living cells, so there is no risk of biological contamination when using or living on meat. Our cell-free system based on cell extract provides us with pre-existing cell components and reduce the need of complicated preparation and purification process. So, it is a cost and time saver.
To standardize the use of the cell-free system and its components, we need to get as much information as possible from the cell extract. That's why we designed a digital twin of the cell-free system that not only represents the dynamic behavior of a Pop Fresh Plus label, but also it predicts the level of polymerase, ribosomes, nucleotides, amino acids, and DNA we need for the project. In this way, we have a fully characterized cell-free system based on E. coli extract.
Wow! And how is it related to the Pop Fresh label? The label was designed with 3 modules. Module 1 for automatic cell extract production. Module 2 is the cell-free system itself. And Module 3 is the putrescine biosensor and Pop Fresh Plus label.
The first module automatically produces the cell extract for our cell-free system using the quorum-sensing cell-to-cell communication mechanism.
We may think that bacteria are very simple organisms, but it is not quite true. They talk to each other sensing small molecules to change their behavior or to coordinate some biological processes, like protein expression.
We use the ESAI quark synthesis system. The ESAI synthesizes small molecules of N-acyl homoserine lactone, or AHL, which are the communication molecules as we can see. ESAR is the transcription factor of the promoter phase RC, and it can inhibit the expression of any downstream gene. When we start to grow our cells in a bioreactor, we are producing the cell extract, and the ESAI and the ESAR proteins. Therefore, the cellular extract will not be produced until we have enough producing bacteria and they have not grown strong and healthy enough.
Only when there is enough happy and healthy bacteria, they communicate through AHL molecules and automatically trigger the production of the cell extract, the polymerase, the ribosomes, and the pure transcription factor we need. Could you imagine? We don't need anything extra because the quark sensing mechanism is in charge of the automatic production of everything.
The second module is the E. coli cell-free system itself. We harvest and wash our cells at the right time, and then we incubate and perform the dialysis of the lysate to obtain the cell extract for our project. The polymerase we produced was carefully selective because it has activity at low temperatures or even under refrigerated conditions. We also produced the pure factor required by our putrescine biosensor.
Our cell-free system based on cell extract has 4 advantages.
First, the cell extract is produced by E. coli Neisel 1917 bacteria, which are probiotics and grass microorganisms, so they are safe and pose no danger to humans. Second, it has plenty of cell resources including ribosomes and polymerases, which are expensive components of a cell-free system. As a result, the high prices of many commercial cell-free systems make them inadequate for industrial applications. Third, we only need to add nucleotides and amino acids to our cell-free system. But don't worry, because they are easily accessible and cheap sources of energy. The main compounds of the cell-free system are fully characterized by a digital twin. So it optimizes the concentration of each component instead of relying on conventional purification processes, and it is a cost-effective and intelligent cell-free system.
The last module is the putrescine biosensor and the bufferage level to sense and display when the meat is toxic or not.
The biosensor acts as a biological switch to turn on or turn off depending on putrescine. A poor transcription factor contained in our cell-free system inhibits the biosensor and the expression of the downstream genes. Normally, when the meat is fresh, there's not putrescine and the label is colorless. If the meat is spoiled, putrescine molecules bind to the transcription factor PUR, derepressing the biosensor and turning on the biological switch.
The bufferage level measures the freshness and quality of meat, producing 2 chromoproteins that are visible to the naked eye. The blue chromoprotein expression means the putrescine levels are low, so meat is fresh. The red chromoprotein production means high concentrations of putrescine, so the meat is toxic and unsuitable for human consumption. The bufferage label has 3 layers made of cellulose acetate, which is a consumer-safe, biodegradable, and environmentally friendly material.
The first bottom layer works as a nanofilter to allow only putrescine molecules to enter. The middle layer is a matrix that contains the dried cell-free and buffer, and a water droplet encapsulated in alginate. Finally, the outermost layer has a transparent film of cellulose acetate to visualize the color changes and protect the system from dehydration and photodegradation.
When we push the label against the meat, and it uses rehydrated the CFS and the water droplet. Amazing, right? Only pop the label and voila!
The 3 models of our label were designed using engineering principles of the DBTL cycle. Since we are in IGEM Design League, our team went back and forth between the design and learn phase.
We also proposed the protocols for the build and test phase. But wait, that is not all. We replaced the build and test phases with our cell-free digital twin.
The digital twin allows us to obtain the optimal growth rate of our cells in the bioreactor. the first harvest time to obtain abundant, high-quality cellular machinery and DNA template, and finally improve some of the parts of the circuit before building them in the lab.
Through several iterations, we designed and optimized the dynamic models that, using only a growth curve as experimental data, give rise to the CF digital twin.
The first digital twin considers the growth curve and the specific growth rate of the bacterial culture as an input. With this information, it reproduces the bacterial growth in the bioreactor. Then, it calculates the amount of ribosome at each time, and using the dynamic model of the genetic circuit we develop, we can also obtain the amount of polymerase and the amount of transcription factor present in the extract. This will allow us to standardize the production process of the cell-free extract.
The second digital twin incorporates a model of the cell-free protein expression reaction, taking into account the three compounds from the first digital twin and external energy sources. This model is then combined with the model of gene circuit, the biosensor, and enable us to establish the condition for build our label based on its computational behavior.
Using our digital twin for the cell-free extract, we performed a successful optimization process. The results show we might produce extract for up to 27 reactions in 2.5 hours of production using a small bioreactor of 20 milliliters. This means that from 20 milliliters of bacterial culture, we will get 27 cell-free reactions and we can produce 13 labels. Having such promising results with such a small volume lead us to think that once the production is scaled up to industrial levels, the cost will be reduced while its production will increase.
Now, how do we assemble the PopFresh Plus models? And the label? Please pay attention.
We design and assemble our genetic circuit using the RFC 1000 loop standard to join different pieces of DNA in different levels. It uses enzymes that recognize specific restriction sites on each of these pieces of DNA. At level 1, transcriptional units TU were built with the basic pairs of level 0. Each transcriptional unit was built in the corresponding target vectors for level 1. Then, at level 2, multiple level 1 transcription units are assembled into the level 2 target vectors.
Once our genetic circuits are assembled, we prepare E. coli initial competent cells to transform our constructs.
We grow the cell in a bioreactor with the appropriate culture medium, antibiotics, and the conditions coming from the cell-free digital twin. Now, to assemble our cell-free system reaction, we combine the cellular extract we produced earlier with the biosensor gene circuit and the additional energy sources. Then, we mobilize the cell-free system on a cellulose acetate matrix and dry for 24 hours in a silica desiccator. We store the water droplet in alginate and place it between the layers of cellulose acetate. And voila! Our PopFresh Plus label is ready.
PopFresh applies the feedback we receive from our instructors, food experts, and stakeholders. We also focus on 3 sustainable development goals.
First, in health and well-being, by preventing foodborne diseases and avoiding the consumption of spoiled meat products in order to reduce the percentage of food poisoning. This will ultimately improve the nutritional quality of our daily diet and benefit the public health system. We aim for responsible production and consumption by providing both producers and consumers with immediate information about the freshness of meat products. We also optimize the supply and production chain, decreasing the use of unnecessary resources and reducing food waste. Zero hunger. We will avoid unnecessary meat waste, promoting a sustainable production that can be distributed to many other people from different places around the world.
Reaching out to experts, we guarantee PopFresh Plus complies with manufacturing standards through biosecurity measures in food.
According to Ecuadorian regulations, PopFresh Plus is not considered as a genetically modified organism, or GMO, as it employs a cell-free system. We additionally perform the risk assessment, to determine potential adverse effects of genetically modified living organisms on the conservation and sustainability of biological diversity in the receiving environment as well as risk to human health. Therefore, PopFresh Plus does not violate national and international regulation on GMOs because E. coli Nisl 1917 is used as a production chassis and it is a safe option.
As part of our integrated human practices, we met with our main stakeholders and learned that our consumers will be very interested in our label because it will allow them to buy food in good conditions while helping the environment. Moreover, butchers will benefit from it because they will not sell a product in bad conditions, warranting more sales and improving customers.
Pronaca is one of our most important stakeholders. It is one of the biggest agri-food industries in Ecuador, with more than 7,000 employees. Engineer Juan Maldonado has told us that about one of the problems they face, which is the ambiguity in setting explanation dates. He told us that this can be solved and verified in the meat products with our label.
Secure by Technologies EC, the company created by our team, where innovation meets food safety.
Ecuador produces 946.4 million of tons of meat per year, which is a big market. According to our survey participants, 66.7% have had problems with the spoilage of meat products. This is where our label comes into play because it is a promising initiative applicable to medicine, biology, agronomy, and others.
In this sense, our potential sources of funding investment will get a small, easy-to-move label. With the guarantee of a top-quality product and innovate qualities, if you are a meat merchant, a supermarket chain, or a food company, this is your opportunity to ensure the quality and freshness of your products.
IGEM is a global community, and IGEM Biotech EC loves to collaborate, being essential for our project. With the IGEM Biomakers team from Peru, we spread the word about the benefits of the usefulness of smart tags based on synthetic biology. With the Theobroma team from Colombia, we coordinated an online scientific coffee to exchange knowledge and advice on food safety, and of course, with a delicious Colombian Ecuadorian coffee. We participated in multi-IGEMers events, all gathered with presentations dedicated to the UN Sustainable Development Goals. And we also participated in an international symposium on synthetic biology. With the scientific community, we have shared very enriching experiences, such as the hackathon organized by Biohack UIO, the first community lab in Ecuador.
We participated in several seminars and workshops on food microbiology to strengthen laboratory and microbiology techniques. Thanks to the IGEM Ecuador team, winner of the Food and Nutrition track of the global competition in 2021, we connected with the children of an indigenous community in Cotacachi, Ecuador. There, we taught synthetic biology by playing with simple experiments. We explained the importance of food quality for our health.
And we didn't stop there. We also gave information webinars of culinary habits for food care to general public using accessible language to talk about science and synthetic biology.
We have reached the end. It is exciting how creativity and science can change the way we eat the world with fresh quality food that provide us with nutritional value.
We foresee that 60% of people will avoid getting intoxicated with spoiled meat. IGEM Biotech, with the PopFresh Plus label, has an innovative solution that guarantees the freshness of meat and contributes with the well-being and health of human beings. PopFresh Plus modular biodegradable cellulose acetate technology shows whether the meat is toxic or fit for consumption.
The label contains the putrescine biosensor, built in a cell-free system with components necessary for its operation, produced by probiotics, accurately quantified by a cell-free digital twin.
It simulates and finds the optimal condition for cell extract, reducing production costs of the cell-free system and making it highly flexible and reliable in large-scale protein production.
PopFresh Plus is just the beginning of a revolution in food safety. We are committed to promoting the bioeconomy and innovation, meeting biosafety standards to preserve the environment and human health. Let's make PopFresh Plus ensure us a safe meal.